All right. All right. How is it going? Let's hear some comments from YouTube. You guys can hear us fine, hear me fine. I think we can zoom in where we want to talk. We can hear you fine. Hi, Alicia. I'm just checking my video. It's fine. Oh, Shonda. That's pretty cool. Before we begin, I want to talk about something. How well do you think titration? Is that something that confuses you? Is that something what do you think? How can someone do
Oh, now the quality is much better now. Okay. ठीक है. Titration is annoying. I think the only difficult part is you have to keep a tally of all the things you're doing. Okay, but let's start. Now, before we begin, I'll just give a little understanding as to how we do it. So there's certain chemicals that are sensitive to, well, there are many chemicals actually sensitive to acids, and they're sensitive to alkalis. And there are some chemicals that change their color in the presence of an acid or an alkali, right? And you know where this is going. So those are known as indicators because we quite literally use them as indicators. Okay. So one such is methyl orange. And the other one is phenolphthalein. And let me just make some more room. Phenolphthalein. How do you spell phenolphthalein? Phenolphthalein. Okay. And what's notable about them is that their colors, methyl orange is red when it's in an acid, and it's yellow in an alkali. Similarly, phenolphthalein is going to be, let's get a different color. Let's do pink. Phenolphthalein will be colorless in an acid, and it'll be pink in alkalis. Okay. And these are called indicators. Let me move this down. These are two indicators. ठीक है. With me so far? I'm seeing some new faces, I think. What are the real colors? Well, that's what they are. Do you mean what their colors are in neutral? We don't really talk about it, but I know for a fact phenolphthalein in neutral color, like it's going to be colorless. Methyl orange, I think some shade between red and yellow. It gets darker, but don't worry about that too much. Like it's either it's an acidic form or like the color is because of an acid, kind of like a litmus paper, it's red when it's exposed to an acid, or it's blue. Okay. All right. So we use this very commonly, and let me just move on. Okay. Let's say I have HCl. So strictly, we'll talk about phenolphthalein. I want to talk about phenolphthalein because I like the color change they have. It's from colorless to pink. I like that a lot more than red to yellow because there's like it's a shade. Sometimes it looks orange, so it's kind of confusing, right? So we'll talk about phenolphthalein. I want to focus on that. So for the rest of this class, we'll focus on phenolphthalein because I like this particular color change. Now, all acids and all alkalis, when they're in solution, they're all colorless. Okay. So they don't have a distinct color or anything. They'll be colorless. You can't tell if it's water or not. Okay. So if I have phenolphthalein in HCl, let me try making a beaker of hydrochloric acid. Okay. This is HCl, and on the other side, let's say I have sodium hydroxide. Another beaker. Okay. And they're all filled, they're all there. And I put a drop of phenolphthalein in both of them. So nothing's gonna happen to this guy over here. It's gonna stay colorless because phenolphthalein in an acid or in acidic conditions will be colorless. But over here in NaOH, it'll turn pink. Shade will be pink. So, and you put a few drops in it, not too much. You put a few drops in it, and it's like putting ink in water. Even if you put a few drops in it, the majority of the color like significantly changes. You can clearly tell the solution is not colorless. It has a distinct color. Okay. Following so far? Easy. I'm just talking about two chemicals here, which will change colors depending on whether they're in an acid or in an alkali. Another way of looking at the same thing is that they will have their acidic color when the pH of a solution is less than 7, or phenolphthalein will turn pink and methyl orange will turn yellow when the pH is greater than 7. Okay. Because if a solution has a pH less than 7, it'll be acidic. If a solution has a pH greater than 7, it'll be alkaline. Following so far? That's a good question, Arisha. Arisha, I'll do one example. Just hold that question and we'll do that. Phenolphthalein, what did I write? Phenolphthalein? That's what I wrote. I think you can't read what am I saying? IE instead of EI? Oh, okay. Thank you for correcting me. I guess it's EI. I don't know. Okay. Okay, let's move on. All right. Now this particular indicator, these indicators are very useful to us because we can do titrations with them. Now titrations, before I start, let's take a look at the same beaker we had Pele. And it's filled with hydrochloric acid. Okay. Now for the sake of argument, let's say it has 100 molecules. 100 molecules of the acid are in there. Exactly 100. Okay. And I also drop a few drops of phenolphthalein in there. Right now it'll be colorless. It'll have no color. Agreed? And I'll also write down an equation of HCl reacting with sodium hydroxide, which will form salt and water. ठीक है. In this beaker, I have exactly, of course, dissolved in water, aqueous. It's aqueous. I'll highlight that. ठीक है. I have exactly 100 molecules. Let's just say, for the sake of argument, for the sake of explanation. We did not have a class yesterday. I started a class very late. No one was there, so I cancelled it. It was kind of some technical issues. Let's go with that. We didn't have a class yesterday. No, it was just a one-off thing. But I think closer to the exams, we'll have classes more frequently. Maybe possibly on Sunday. Past paper sessions, we'll have them closer to exams, especially the last month. ठीक है. So these are the two main indicators you want to focus on, right? Okay. All right, let's continue. Now, my question is, phenolphthalein is already in there, right? Phenolphthalein is already in there. What's going to happen if, now we're talking about molecules. What's going to happen if I put 10 molecules of NaOH in there? Note that to start off with, this has 100. If I put 10 molecules of NaOH, will the color change? Some people are saying no. ठीक है. And this is because when you have 100 molecules of NaOH, as soon as you put NaOH in there, it'll react. It'll react to form what? It'll react to form salt and water. So 100 में से all of this will react and you'll be left with 90 molecules of, right? Molecules of, what do you call it? Hydrochloric acid, and you'll produce 10 molecules of sodium chloride and 10 molecules of water, right? So the solution is still acidic. It's still 90, right? Because as soon as you put NaOH in it, as long as there is acid inside, it'll react and disappear. It'll turn into salt, which is neutral. Sodium chloride is neutral. Water is also neutral. Well, yeah, right? So this is still an acidic solution and the color will remain colorless. Nothing's gonna happen. ठीक है. And let's say you put 50 in there. You have 100 to begin with, and you put 50 in there. ठीक है. And so what's gonna react is 50, all of it will react, and you'll be left with 50 hydrochloric acids to form 50 water. 50 salt and 50 water. Molecules की बात कर रहा है. You don't get these numbers, Saad? Okay. Let me start one more time. We're talking about 100 molecules. This is what I put in. This is what I'm putting in the beaker. This was already there, right? We started with 100 HCl molecules in this beaker. You can think of them as moles or something else, right? And I'm adding 50 to it. Now in white, this is what I'm putting in. So as soon as I put them in, they'll react to form something else. So they'll disappear, maybe or it won't be, right? It might or might not. So Nietzsche, I'm looking what's left behind after the reaction has taken place. So if you put in 50 sodium hydroxide, 50, all of it will react, and I shouldn't put 50 here. All of it will react and turn to 0. And you'll be left with 50, and you'll produce 50 salts and produce 50 water molecules. Does that make sense? Saad, are you following? ठीक है. Just where I'm being a little more technical than necessary. ठीक है. Only when you put 100 will this turn into 0 left, and this will be 0 left, and you'll have salt, and water. Sorry, why did I write H2? Only when you put 100 in there will all of it will react and complete neutralization take place. Now this solution right now is not acidic at all. It's completely neutral. It's exactly neutral. There's no acid left. There's no sodium hydroxide left. No alkali left. It's completely neutral. Okay. Now, will the color change right now? You know what? Depending on the indicator, sometimes it does, sometimes it doesn't. Yeah, indicator का color same रहेगा. Exactly. ठीक है. Sometimes it might change, sometimes it not. It doesn't really matter. And I'll explain the reason for that in a bit at the end. Ask me again, sir, what about it's not at the neutral point? You know, this, I'll answer that. Okay. As soon as you put in, because you can put how much, however, we kept adding sodium hydroxide over here, right? We kept adding it. As soon as I put 101, when this turns into 101 molecules, I have a surplus. I have one NaOH molecule that has no acid to react with. So this has turned into an alkaline solution because it has alkali in it. And all of a sudden, the color will turn pink. As soon as sodium hydroxide is in excess. How will we be able to identify it? I'm telling you. I told you this is a hydrochloric acid and this is what we're doing. Exactly, I told everything this. How will we identify it? That's not really a concern right now. Okay, you want me to repeat it? I am saying at 100, we agreed that it would be completely be neutral. There would be no NaOH in the solution and there would be no acid in the solution because all of it would have turned into sodium chloride and water. This would just be salt water and the color would still be colorless. Very likely. Okay. But as soon as I put one more molecule or one more drop of NaOH in there, because I'm dropping it in there, right? I had a beaker and I was pouring NaOH in there slowly, one molecule at a time. As soon as I put 101, I have no acid to react with, and I have one extra NaOH molecule in this solution. So isn't this solution alkaline now? Because there's no acid in there and there's only NaOH that has nothing to react with. So it's alkaline. And the indicator will turn pink. Somewhere in between, no, it won't be. Because either you have the three states, no? Either hydrochloric acid is in excess, either they're equal, or either NaOH is in excess, right? Right now, because all the HCl is gone, because it reacted with the first 100 molecules, you have one at the 101 molecule count, there's one more molecule left, or like one extra molecule. So the entire solution turns pink. And mind you, it'll be a very light color of pink. The more alkali you'll add, it'll get darker and darker. Okay, following so far, I think I'm a little more technical than I should be, but I hope this makes sense because I want you guys to think in numbers. Agreed? What do you guys think? I'm waiting for you guys. Yes, so if only NaOH is in excess, will it turn pink? Or you could argue, because you're barely, it's so close to the neutral part anyway, you can also, call it they're in equal proportions, more or less, but we'll get to that. We will get to that. Okay, people are clear online on YouTube. Okay. So this technique can be used to do what? This technique can be used to identify exactly how much of concentration we have. Okay. Let me give you an example how I would do this. Let's do the same experiment again. Okay, let me just draw it. ठीक है. Let me draw it. I am so thirsty, I forgot to bring my water bottle. I have hydrochloric acid over here. ठीक है. I have hydrochloric acid and it has some unknown amount of molecules. I don't know. Now I start putting in NaOH like before. Right? NaOH. Start putting it the same before, and I'll rewrite the equation. And that's a really nice red. ठीक है. Now I don't know how much there is. Now I drop it, you know, molecule by molecule, molecule by molecule. I'm doing it, I'm doing it, I'm doing it, I'm doing it, I'm doing it. I'll stop doing that. ठीक है. We're doing it. And let's say at my 79 or, you know, some number, let's say 120. I don't want it to say 79. Let's say when I add 120 molecules, the solution turns pink. The beaker, the mixture turns pink. Does that tell me I have exactly 120 molecules over here? Can I argue if it's not 120, it's very close to 120? Can I argue that? I mean, 119 hoga na otherwise. If at 119 it didn't show a color change, because I'm adding it molecule by molecule, right? And at 120 molecules, if it changes color, I could say 119, but I don't want to, and you'll see why. But right now it's 120 molecules, very close to it. एक molecule से क्या फर्क पड़ता है? Right? Can it be more than 120? If hydrochloric acid was more than 120, if this was more than 120, the color would not turn pink. Let's say it was 140, and I put 120 NaOH in there. This would react, 120 would turn into 0, and I'd have 20 HCl molecules in excess. So HCl molecules यहाँ पे 20 molecules रहेंगे. And if they're there, the solution will be colorless and not be pink. How do we know the entire solution, how the entire HCl has reacted? Because the color is pink. It's pink because the phenolphthalein is now in an alkaline solution. Right? Arisha, following? It's pink because it's in a predominantly alkaline solution. Because the phenolphthalein will be colorless in acidic conditions and pink in alkaline conditions. As soon as it turns pink, we know the entire thing has alkalis in it and no acid. You get it? Great. Great. Brilliant. ठीक है. I know I'm being a little number intensive, but you know, if you get it, it's great. ठीक है. And this is essentially what we do. I figured out the unknown molecules of hydrochloric acid. Right? Can I say if it's very close to 120 approximately, if not accurately? This is 120 molecules. Does that make sense? All right, can I get like some positive feedback if you guys get it, so I know when to move on? You guys getting it? Just type spam yes, or if you guys can do a thumbs up. Not on YouTube, or that thumbs up stays, I don't know. But can you guys do a thumbs up? Okay, you guys are getting it, just spam yes. ठीक है. Absolutely brilliant. ठीक है. Now in real life, this is going to be a bit trickier. Because you do this not in counts of molecules, but you deal with concentrations. और उसमें moles आता है. Now don't get intimidated by the moles, because we'll do a lot of moles in one titration question. बहुत heavily intensive titration moles होता है, but if, you know, it's nothing more complicated than what a cook is doing to make his food. Honestly, swear to God. And I think we've had this discussion earlier when we were doing moles. Okay, so let's see how this works. Let me show you a real titration. And we'll also answer why we're choosing 120 rather than 119. I think Arisha's probably still has that question. Okay. Okay. I have a beaker of hydrochloric acid. Okay. Let's say the volume of this is 25 centimeter cube. And the concentration is unknown. Okay. Now what I'll do is again, I'm adding NaOH to it. Now NaOH, you don't know the moles of it. What you do know, let me not put an arrow. Let's say the concentration of NaOH is 0.1 moles per decimeter cube. And the next statement is something the question will tell you is the volume at which you noticed the color change. The volume at which the acid was neutralized or you saw the color change was, let's say, 27 centimeter cube. What is the concentration of this acid? Now note, why aren't we just talking about moles? We'll take the NaOH in excess. Not in excess, but ever so slightly in excess. As soon as the color change appears, we'll stop. And that's what they did. Because if you excess में तो, you can put like 2 million tons of it inside and that'll still be in excess. So you just stop as soon as the color change happens. ठीक है. Now let's see this calculation taking place. Now in solutions, पहले तो मैंने एग्जाम्पल समझाने के लिए बोल दिया हम तो मॉलिक्यूल से डील कर रहे हैं and I could have easily said moles, right? But when you're doing this, you can't count the moles of something, right? Because it's in a solution, how would you know what's going in? But because moles is not something that's directly measurable, but what's directly measurable is volume. Because beaker, cooper, graduations होती हैं for one thing. Actually, you use a very different instrument in this case, which I'll show you in the next example, how you actually do this. But for simplicity's sake, we're using a beaker that has graduations on it. So we know exactly what volume pe there was a color change over here. And that was 27 centimeter cube. And let's try down the equation again. I am in love with this red color. Okay. Now everything is given to me in concentrations and volume. What I want to do is figure out, note what the question is. Question has given me details of concentration and volume, and hydrochloric acid, they're asking for the concentration, right? Now, to find this out, I would really have preferred to know what moles were used over here. Can I find that out? Is there a relationship between concentration, moles, and volume? Yes, there is. Concentration, what color should I use? Concentration is moles upon volume. Isn't that the case? So the moles right now are equal to the concentration, which is 0.1, and the volume in decimeter cube is 0.027. 0.027. And this comes out to be 0.0027 moles. Is that understood, that the amount or the moles of NaOH used are 0.027? 0.0027 moles? How do I know? I know the concentration, I know the volume that was poured in here. So I can easily calculate the moles. Rania, online you won't be asked to find the unknown molecules. That was just my example, but normally you do. Just find out the concentration or the moles, either or, depending on the question. People get it? Zoom people, are you getting it? Are you getting it? Okay, easy, right? This is done. This is easy. So if I zoom in a bit over here, I think I'm going to start zooming in a lot more. This is 0.0027 moles. The relationship we saw earlier between hydrochloric acid and NaOH is 1:1. For every NaOH added, there was one HCl, or like they react in the ratio 1:1. So if there were 0.0027 moles of NaOH, which we just calculated, in HCl, or in the original solution, there should be very close, if not exactly the same number of 0.0027 moles. Okay. Titration, you don't really need to know the definition. It's just a process in which you use to identify the concentration of, or the amount of something that's the unknown. Titration is a procedure which we do, and I'll explain that a bit more. Okay. Let's focus on this concentration. Let's not jump ahead, thoda. Okay. Is that clear? Do you guys understand this part? This is clearly logical, right? This is the same thing we did earlier with longer steps. If this has to be 120 molecules, this also has to be 120 molecules, or at least very close to it. And that's what I'm saying over here. If this was 0.0027 moles, this has to be very close, if not exactly 0.0027 moles. Agreed? Yeses or no's? My Zoom people? Hybrid Nugget has sent me a react. Okay, people are getting it. You guys are very quiet today. Ramis did not understand. What part, Ramis? Ask your question. I'm waiting for you guys to ask questions. We're taking really long because a lot of people get it. The last part. Dekho na bhai, dekho na, dekho na, dekho na. Do you understand this part? I put exactly 120 molecules of NaOH in the solution, and at the 120th molecule, this turned pink. So if this was 120 molecules, this has to be also be 120 molecules, or very close to it. So I say it's 120 molecules. Okay. Similarly, I don't know the moles of this initially because they gave me the concentration and the volume, but I figured out the moles. So if this was added, this many moles of NaOH were added through this solution to turn it to pink, or have the phenolphthalein turn pink, that means in the original solution there were 0.0027 moles of HCl. I'm suffering from midterm depression because I had to check the papers. I'm joking. But yeah, I think the winter blues are upon me. I'm not doing too well in that sense. I'm kind of, I don't know. But let's get back to this. I hope this is clear. And if it's not clear, let's come back to this because you guys are taking a really long time asking questions or replying to my questions. So I'll just move ahead. So the question initially was asking, what is the volume? Oh, hydrochloric acid ka volume, you have 25 centimeter cube of it. Find out the concentration. So now you know the moles of hydrochloric acid. So for hydrochloric acid, you can perform this calculation right now. For HCl, you could say concentration is again moles over volume, and your concentration is your unknown. Your moles you just very accurately found out, 0.0027 divided by the volume isn't given to us in centimeter cube. I'll convert it into decimeter cube because I want to keep that consistent. Is that right? I think that's wrong. 0.25, right? 1, 2, 3. Yeah, that's it. Decimeter cube, and it's going to be 0.025. And I was given the answer by Messam, who's saying it has to be 0.108 mole per decimeter cube. That's the question. We just did a question. ठीक है. थोड़ा, oops, wrong pen. Thoda, like, it's a really long procedure, I guess. But you know what? More often than not, it remains the same. So the calculation turns into routine very quickly. How many of you guys follow this? I found out the concentration indirectly of hydrochloric acid by reacting it with NaOH. Does that make absolute sense? When I found this, when I finally understood titration, I thought it was the most smartest thing people were doing. Like, wow, like, that's how you find out concentration? Yeah. So the moles of HCl you mentioned, why were the moles of HCl were wrong? No, we found out the concentration. The moles are correct. These are moles correct. These are correct. What do you mean? Yeah, don't get confused between moles and concentration. Titration, I should look it up. Titration is just this process of finding this out. How would you formally define it? Okay, I'm just gonna copy what Wikipedia has to say, but I wouldn't worry too much about the definition. It's this procedure what we're doing. They will not ask in the paper. They do not ask what titration is. They ask you to do it. ATP में ये बहुत होता है. This is probably 50% of your ATP calculations. Okay, not 50%, but yeah. This is the most common calculation-oriented lab procedure for chemistry, even in A levels. ठीक है, this is what titration is. You found out the unknown for this solution by reacting it with something that's known. Now, most commonly you can do it with other chemicals as well that react with each other, right? You do it, well, O levels and A levels will 99% of the time will do it between acids and base. Acids and alkalis, or acids and base. That's how you do titrations, primarily in O and A levels. Okay. The other thing is, yeah, indicators are very important. Indicator. Okay. let's get, and this is not how you actually perform a titration. Let me show you how you actually perform it. If you guys understand this, I'll show you how you actually do it. Now you don't need to draw what I'm drawing, or I'm just trying to give you an idea how this works. Because what the issue is, if you haven't realized already, is this needs to be really accurate, right? The more accurate your measurement of the volume is, the more accurate your answer over here. Right now I'm just saying 27, but it's really hard to pour from a beaker drop by drop. So you understand this is a really bad instrument to use to figure this out. They do not ask the titration की definition in the paper. ठीक है? So you begin with, if we had to do the same experiment in a lab, this is how you would do it. You would take a conical flask, and you have the acid inside. You use a conical flask because you can grab it from here and kind of flick your wrists, right? And it stirs really well. So during the process, you're stirring it a lot. ठीक है? Today's class for 1 hour, sir, today's class for, you know what? I'm okay with that. Let's see if we can stretch it that far, if we have the stamina. If you want a longer class, I'll give you a longer class. I was actually waiting all day for this class. On top, you have a burette. A burette. A burette is a device which is a long glass tube with graduations on it. Okay, I can't show you a picture right now, but if you guys can Google it, that'll be great. At the bottom, there's a tap. A tap is a, nalka. छोटा सा tap बड़ा अच्छा सा लगा होता है. ठीक है? And this is graduated. By graduation, I mean they're markings of volume. And what you do is you put a funnel on top and you fill it with NaOH. Or depending on whatever you need, you fill it up with that. ठीक है? You fill it up. Let me just add more graduations here. And most common burettes will start, अच्छा, इनकी graduations उल्टी होती है. They start from 0 centimeter cube. And the most common ones will be 50 centimeter cube. And you'll, of course, you can find them for different sizes, but this is ideal for our case. ठीक है? This is how you do it. So instead of, so this tap is very accurate. You can control it where it can, the alkali can run like a stream, or you can twist it where it's drop by drop. And like you can really slow it down to the point where like the drop is coming in every 5 seconds or so, like ploop, 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 right? Really slow ho jata hai. So as soon as that color change happens, you can see it immediately there and stop the tap. So you don't put even one drop in excess, because as soon as the color changes, technically it's already kind of in excess. So you don't want to put extra drops in there. If you put an extra drop, you'll get the wrong volume key reading. Does that make sense? Does that make sense? Don't worry, Ramis, you're back. ठीक है, but people are not replying. I'm kind of Hassan Shah Duha. What is the reading-based instrument? It's called a burette. Now my spelling's terrible. I was also reminded right now with phenolphthalein, but this is a burette. I believe it has 2 R's and 2 T's in it. It's called a burette. Fancy name. It's just a simple thing. ठीक है? People are getting it. All right, chalo. This is how you do titrations. ठीक है? The indicator goes in before the reaction starts. My favorite would be, for this case especially, would be phenolphthalein. I think the I this time around is after the E. Okay. And that's it. Now, of course, there are other things accounted over here because the beaker won't float in air. You use a clamp, and to see it clearly, sometimes you use a white tile at the bottom, but more often than not, you actually don't see that. You can actually use a piece of paper to see it clearly. By the way, the color pink will be very, very light shade of pink because it's barely alkali in there, right? Because you only put a drop of phenolphthalein in there. You don't want it too much. ठीक है. Okay. Are you guys ready? Do you guys want to do a question? Or do you guys want to ask any questions before we move on? How would we know which indicator to add? Well, you could add like, you know, that's actually an interesting question, right? So you choose the best one, right? And I think in this particular case, both the indicators I named were fine. Where are they? Methyl orange and phenolphthalein. Now, because this red turns to yellow, I've actually used both of them. I think colorless to pink is a more obvious color change, right? It's colorless, there's nothing, all of a sudden there's a shade of pink. So it's more obvious than something going from red to yellow, because there's, you know, sometimes red might look like orange in some light, you know, like, and it's a gradual change sometimes. So yeah, but you can still use it. It's pretty distinct even with this thing. It's meant to be used over here. ठीक है. ठीक है, but you can use either right now. Yeah, in P4 you'll have to do that. Then you subtract it. There's a table given to you. There's actually a whole table on this. Like how you do this experiment in the lab is through table. And what you end up doing is, actually, I'm happy Dua asked that question. First you do, because this experiment, if you think about it, you don't know at what volume this color change will appear, right? It could be at 0.1, it could be at 1, it could be at 20, it could be at 49, you know? So you don't want to, if you start doing this drop by drop, right? If you start doing it drop by drop, it will take you hours to do this experiment. So what you do is you do a trial run in the first round. You do multiple runs. Well, trial went away. You do trial run the first time. So what you do is you have your base over here, your alkali, and you let it run in a speedy fashion. Drip aa rahi hoti hai yahan pe na? It's flowing down. And as soon as the color changes, you stop and you mark the recording. Now, very likely, you know, obviously because it was running so fast, human reaction, error time, everything, you can easily pour more NaOH in here than after the color change, right? But you have a good idea. Let's say this stopped at 30 centimeter. You stopped it at 30 centimeter. So you know, your solution is going to be, or your actual reading that should come up would be close to 30, but less than 30. So once you know that, you restart this experiment and you let it run to 25 centimeter cube fast. And when you stop at 25, there's no color change. Then after 25, you let it run drop by drop. So that saves a lot of time. Okay, but I think we're getting into a little more detail. And then you do this experiment 3 times to make sure each and every reading was correct and there was no misstep by people. So you do it multiple times and then you take the average out of it. Okay, but if you didn't follow this, we'll come back to this. Let's do a question now because people aren't really asking questions. Let's see if we can do a question. Okay. Now this question is purely for your calculation practice. So they're not giving you any color change, and questions normally won't be giving you color change वगैरह का information इतना detail में नहीं करेंगे. They're saying 25 centimeter cube of sodium hydroxide reacts with 21 of 0.2 mole per decimeter cube. So you want to figure out the concentration of sodium hydroxide. Figure out the concentration of sodium hydroxide. Actually, let's write it down properly. Figure out NaOH concentration. Figure this out, because what's happened is they did the experiment and they used 25 centimeter cube of some unknown amount of sodium hydroxide with unknown concentration, and they realized the color change occurred at exactly 21 centimeter cube of this acid at 0.2 mole per decimeter cube. Shall I do this question, or do you guys want to start doing this question? Hey, 14 likes already. But 6 people watching, but 14 likes. Well, I don't follow that logic, the math. Do I have bots liking my video? I'm flattered. We'll talk about that. The best 2 readings, how you choose is how close they are to each other. Because one is going to be your rough reading, and the other 2, which are 2 closest to each other. And that makes sense, no? Because if you have, let's say, 3 readings, and I'm only talking to Dua right now, I don't want to confuse any people. Let's say your reading was 31 centimeter cube, your second reading was 27 centimeter cube, and your third reading was 28 centimeter cube. They're actually in decimals and a lot closer to each other. But out of the 3, if twice you're getting close to 27 and 28, there's a good chance that this is probably an incorrect reading. So you'll pick these 2 out of the 3 rather than this 2 or these 2, right? That's the reason behind it. No problem, Dua. Okay, people on YouTube already have the answer, which is surprising because they get the video late. Let's start this question. Do you guys want me to do this question? It's exactly the same as what we did with HCl reacts with NaOH to produce sodium chloride and sulfuric acid. ठीक है. Massam got the concentration. Okay, good. ठीक है. Now, what is this telling me? This is telling me the moles of hydrochloric acid. This is going to be, let me make more room. This is going to be, moles are going to be equal to C times V, which is 0.2 times 0.021, which is going to be 0.0042 if I'm not too wrong, moles. I'm just doing this in my head. Check if this is correct. Should I just use a calculator? Maybe I should. Calculator, here I come. 0.021 times 0.2. 0.0042. Absolutely. So this time around, because we have the information for hydrochloric acid, we'll write it here. This is 0.0042 moles. So if I ended up using 0.0042 moles, the ratio between them is what? For every 1 hydrochloric acid molecule, or every 1 mole of it, you'll need 1 mole of NaOH or 1 molecule of NaOH, right? So this has to be 0.0042 moles as well. And once you know this, you found out the missing moles of sodium hydroxide, you can find out the concentration. So this goes here. Let me, I wanna divide this and make this look neater. I think between me and Sir Bilal makes it look so neat and effortless when he's working. It's truly, really enjoy that. Okay. And so the concentration is going to be, I don't want that color. I don't want that color either. Let's use this one. Concentration is equal to moles per volume. The moles are 0.0042 and the volume is 0.025. And I think people are saying it's going to be 0.168. 0.0042 divided by 0.025. 0.168 moles per decimeter cube. What do you guys think? What do you guys think? Easy? Was this easy? Did you guys, were you guys able to do it? Okay. Should we do more questions? Do you guys want more questions? Not too excited? Okay. Okay, these were easy questions. We kept talking about the same thing. Okay. Anyone having trouble with this? Anyone having trouble with this? What I would do if someone just brought me a glass of water right now. Masam, you say nope, not yet. Why are you saying that? There's so many messages retracted on YouTube. I don't know what you guys are saying. Hey, 15 likes. 15 likes, wow. Wow. Wow, wow, wow. Wow. All right, you guys want me to do this question? Give harder questions? Give harder questions? Let's try. Harder questions? Wow, 16 likes. Where is the legend, Mr. Bilal Hamid? Mr. Bilal Hamid has asked me to take Saturday's classes. He'll join you on Monday. The legend. The man. The legend. Okay, let me look at harder questions. But can we do this one just in case? Harder questions. I'm looking for harder questions. Meanwhile, yeah, that's a good question, right? Now, Masam is asking, how can we observe the color change if we pour HCl into NaOH? So it starts with pink and going to colorless. So that's going to be a difficult thing to see. So between the two indicators we talked about, maybe use methyl orange. So it pretty much suits your needs, Wali Bath. Don't worry too much about right now about what indicator to choose. But yeah, like I think even if you use phenolphthalein, it's fine. You won't have an issue. But yeah, but the color change would be that the solution from pink would turn into colorless. And that's, I think, a bit trickier to observe because how our eyes play tricks on us. Like, is it really there? Is it gone? I don't know. But if it's colorless and even a slight amount of pink shows up, that's clearly visible. ठीक है. I'm actually trying to find hard questions. What is a hard question? I think the hard question would be where you're asked to balance an equation. "25 centimeter cube of ammonia solution reacts with 33 mol. What is the concentration of solution in grams?" Okay, let's do this after that. ठीक है. Are you guys doing this? Let me start. YouTube is busy. And I'm not Sir Bilal Hamid San. He was my teacher. Thank you, I guess. I like my accent too. I was reading some comments. People thought I was from Cambridge. Very specific. Okay, that didn't show up. Okay. Let's do this. 25 centimeter cube of sodium hydroxide reacts with 17 centimeter cube of 0.1 mole per decimeter cube sulfuric acid. Now, let's figure out the moles for this first, because it's turning into routine. The moles of sulfuric acid is going to be concentration times volume, which is going to be, concentration is 0.1 times 0.17, is that right? And this is going to be 0.0017 moles of sulfuric acid. ठीक है. And let's write our equation down. Now here's the real challenge. You have to appreciate one thing. NaOH reacts with sulfuric acid not in the same ratio as hydrochloric acid. To be able to write this equation down and balance it is something you'll need to learn. I think you'll need 2 NaOH, and I think right now it's balanced. ठीक है. So the ratio between these two guys is for every 2 to 1, right? If I have 0.0017 moles for sulfuric acid, how much would this be? Twice the amount? Would this be twice the amount? 17 times 2 is 34. It's going to be 0.0034 moles. Let me align this properly. Forgot to balance? Aha! See? Be careful. Be careful. ठीक है. Once you know, it's the same as the next one. Okay. So what's the last bit? We calculate the how many of you heard how many of you are hearing a cat? Is it yelling? Do you say a cat yells? Meowing? But what if it's in that tone? So the concentration is going to be the moles. ठीक है. Divide this by the volume, which is going to be 0.025, and this comes out to 0.0034. Divide this by 0.025, 0.136 moles per decimeter cube, and that's my answer. Some people are saying 0.147. Is the equation balanced? Oh, I think should be a 2 over here. Where's my blue? Is the equation balanced now? Yeah. 4 hydrogens, 4 on the left, oxygens, 2 oxygens. Yeah, it looks balanced now. Equation is not balanced, but I got the same answer, correct answer, because these two ratios were fine. I forgot to put a 2 over here. ठीक है. Does that make sense? Everyone clear on this? Now the question might get difficult sometime around, so can we turn this into steps? Step 1, step 2, and step 3. And you guys already know this. ठीक है. Find the known and convert it into moles. Find the known, convert it into moles. Step 2 is find the unknown by using the moles you just figured out. And step 3 is find whatever is required by the question at the end. And if you've noticed, this is exactly what we've done routine by routine. Step 1, step 2, step 3. This was step 1. Actually, yeah, I think वहीं पे था ना? This was step 1. I did it here, wrote it there. This was step 2. And this was step 3. Exactly the same. ठीक है. All right, here's a slightly different question. But yeah, I have some routine questions. Trying to look for, okay, maybe we can do this. Okay, let's do this after this one. I don't want to, I think anyone weak in moles might just start screaming if they saw the other equation. Or start. Can we try this? Notice what the question is saying at the end. Oh, it's 7:08. Though if you need help, I think Tribe is a good place. Just ask your question there. I know we've been kind of not too active. You can always, we're here 5 days a week. You can always ask questions. You can also post questions on Tribe. That's why it's there. You can take a question, take a screenshot of it. Mind you, just take a very neat one if you can and post it on Tribe and we can discuss it. I can send the solution. Sriblal's there as well. ठीक है. Oh, I think there's a lot of background noise because do you guys hear a lot of background noise? No background noise? Okay. All right. Hey, 18 likes. Can we beat 25? Kinda hear, Devil hears a bit of background noise. Why on YouTube do I see message retracted for all of you guys messaging, but I see it fine in my app I'm using? Do you guys are looking at this? Abdul Rahim, Hafsa Ahmad, their message retracted. I think they're taking back after they write something down. I think that's what it means, message retracted. Okay, let's do this question. Do you guys want to continue class longer or do you guys want to call it a day? You decide. I think I have some energy in me. No as in no continue or no don't continue. Okay, in a titration of ammonia solution react with ACl, what is the concentration of this? Okay, of ammonia in this thing. So step one is I want to convert this into moles. It's going to be moles concentration times volume. My concentration is 0.8 times 0.0333, and that turns to 0.00333. Now don't round off over here, 3 significant figures, or try not to round off. Just make it a practice of not rounding off while solving question right in the middle of this question. Round off at the end. What is the equation of ammonia reacting with hydrochloric acid? It's going to be NH3 and H3 with HCl to form ammonium Tiga. And the ratio between them is 1:1. Yes. So if this is 0.00333, this has to be 0.00333 because the ratio is 1:1. And I can figure out the concentration, but wait. They're asking something else. They're asking for grams per decimeter cube. How many grams are there in decimeter cube? Okay. So this is a different way. Actually, I shouldn't have mentioned this question because they don't normally ask this. But on the quest of finding a difficult question, I was resorted to this. But if you apply some common sense, it's going to be really easy to do. You want the concentration in grams. So if you use this value, it's going to be moles per decimeter cube. And if you convert this value to grams, if you convert this into grams, then find out the concentration using that value. It's going to be grams in decimeter cube, right? And we'll do that. We will do that. So concentration in grams per decimeter cube. First, I need to turn them into grams. So how do I turn this into grams? So mass is the number of moles times the MR, which is 0.00333 times the MR, and the MR for NH3 is 14 plus 3, 17, times 17. What's this number times 17? This value is 0.05661 grams. Okay. And my final concentration in grams is going to be the mass, because they want me to in grams per decimeter cube. They want it in, okay, let's get a darker color for this. Grams per decimeter cube. Still don't like that. Okay. Mass over the volume. Mass is going to be 0.05661 divided by the volume. The volume is 0.025. And this is, wow, you guys are done. Divide this by 0.025. 2.26 grams per decimeter cube. $2.2664. I rounded off. Actually, let me check. 2644. Yeah, I think it's correctly rounded off to 3 significant figures. Why is your voice different? Because I have a sore throat. Why is my voice so different? This is my new act. I do accents, different accents in every class. Do you guys understand? Arisha, Dua, Mesam? There are only 3 people left. People online, do you guys understand? Straightforward? Is this clear? Is titration much easier now? Do you guys want to do more questions next class? Next class with me. I think Sir Bilal will continue with what he's teaching. Do you guys want to continue titrations, or should we try something else or more difficult questions? You guys want to do, I guess we can look at titrations more. ठीक है, let me compile some past papers and we can do those. ठीक है, past paper time. People online are saying that as well. ठीक है. All right, chalo. Let's end it here because the 3 people now, I think you guys are done as well. Just out of curiosity, Arisha, Dua, Mesam, do you guys have more energy, enough energy in you to continue for half an hour more? Enough energy? Con, kun, what? What did Arisha type? Oh, and that means thank you? What language is that? Con, kun ka? Oh, you have physics? Okay. Yeah. Chalo, I was going to end anyway. I'm kind of tired. I've been looking down for an hour, 15 minutes. My neck hurts. Chalo, guys, thank you for joining in. Thank you. I hope you enjoyed it. Please, I would very much appreciate if you guys want to leave some feedback in the comments on YouTube, or let us know how classes are. Was it too easy, too difficult? Do you want it faster? Do you want it slower? Some feedback from you guys would be great because it makes it more... oh, it's Thai. The language Kon Kunka is Thai. Let us know, please. Let me know as well. Comments, below the comments. ठीक है. Arith hoga? Arith hoga? Arigato? Is that what you were trying to say? Arigato? Alright, chalo, but I'm gonna end it. Bye bye, guys. Take care. Have fun. ठीक है. Well, what fun, right? Exams are around the corner now. Well, not around the corner, but soon. But alright, let's end it here. Bye, guys. Take care. Interesting. I hope you guys enjoyed this iteration of titration, how I explained it. Okay, bye bye, guys. Take care. Bye bye. Take care. Bye bye, guys.